The current cosmology is an open mystery to science. For centuries, humans have been trying to uncover the underlying mysteries of the universe, but most of the time, our theories fail to explain it. Right now, we don't have any exact theory that can explain how everything started. But with the help of the most powerful telescopes out there, we are now able to find clues that may reveal how everything in the universe came into being. Recent images from the James Webb telescope revealed a massive structure behind a much brighter, closer group of galaxies called Pandora's cluster. This incredible discovery just shook the field of astronomy. Scientists around the world claim that the Standard Model could not explain this massive structure with our current theories. There's a lot of confusion among the general public about the Big Bang model, and it's obvious because the term Big Bang is a wrong word to represent the Standard Model. Nobel laureate Roger Penrose states that the name Big Bang refers to an explosion that appears to be chaotic. It is a state from which no order can arise. However, the Big Bang model is not like that at all. This model doesn't say anything about where everything came from. It only says how things evolve over time after a sudden expansion. The Big Bang model itself is an incomplete view of the beginning of our universe. This model assumes that our universe once had a beginning, then particles interacted with each other over time to form the first stars and galaxies. The Big Bang model does not say anything about the starting point. This model only describes how our young universe evolved over time into the present universe. Right now, we have no idea of where the universe came into existence. We only know what happened after the sudden expansion of space and matter. Recently, the Webb telescope has brought up some possible evidence against the Standard Model, and the telescope's new findings has made astronomers to reconsider existing theory, which has been a wonderful tool for understanding the present-day universe. There is a serious problem with our Standard Model, which works perfectly when we try to understand cosmic events near us, but fails when we try to understand the early days of our universe. As the Standard Model only talks about the evolution of stars and galaxies, assuming that everything came from a single point. In a recent Webb image, for the first time, astronomers have detected a protocluster of 7 galaxies at a distance that astronomers refer to as redshift, or a mere 650 million years after the Big Bang. When astronomers were observing Pandora's cluster, they found a massive structure lurking in the background, which they confirmed, with spectroscopic tests, was indeed a protocluster of early galaxies, and it surprised astronomers. They did not expect that such large clusters would exist only a few million years after the Big Bang. Furthermore, this cluster is very large, and the galaxies in this cluster are more massive and mature than the Standard Model predicts. Tommaso True, a member of the protocluster research team at the University of California, Los Angeles, says, "It is amazing the science we can now dream of doing now that we have Webb." With this small protocluster of 7 galaxies at this great distance, we had a 100% spectroscopic confirmation rate demonstrating the future potential for mapping dark matter and filling in the timeline of the universe's early development. Also, the Standard Model says there should be an order of galaxies according to their size and mass. But a few days ago, the Webb telescope discovered way more massive and mature galaxies only a few million years after the Big Bang, and this discovery completely shatters the Standard Model's approach to galaxy evolution. So what's really happening here? Is there something missing in galaxy evolution in our Standard Model? Recently, some scientists have suggested that maybe the Standard Model's assumption that our universe evolved from a singularity is wrong, and maybe our universe had no beginning. There are many other possible existing theories to model the universe. For example, Nobel laureate Dr. Roger Penrose believes that our universe may be one of many universes connected in a circle, and the black holes from the previous universe have accelerated the expansion in the early universe. Also, Some scientists believe that
The argument is that our universe, as we thought, is not the whole story. That this future, remember the Escher picture, can be squashed down, and now it becomes the Big Bang of the next eon. And so this is what I call conformal cyclic cosmology, that we are here. There was one of these eons, I'm calling them an eon. I looked up in the dictionary to make sure an eon, A-E-O-N, was...
maybe this universe is infinite, and it has no beginning and end. The universe is surrounded by nothingness. We are in the infinite ocean of space. Our universe is a part of an infinite void where nothing used to exist. But over time, things came into being from this nothingness. But this nothingness is something that allows things to happen. It is infinite and has existed forever. This idea may perhaps explain how the universe can be unpredictable at times and how our universe evolved over time. One of the beautiful things about physics is that it's deterministic. If you know all the properties of a system and the initial condition, then the laws of physics can perfectly predict the future of the system. This is what allows physicists to make predictions about how particles in the entire universe will evolve, but that universe can be both deterministic and unpredictable. Sometimes it feels like the universe has a chaotic nature, such that we cannot predict the weather because a small error in the initial data can lead to a significant change in the outcome. Some scientists believe that chaotic systems are everywhere and dominate the universe, which is why we will never be able to fully predict the universe. Well, the formation, structure, dynamics, and evolution of the universe have always been of interest. It is commonly accepted that modern cosmology began with the publication of Einstein's seminal article in 1917. Applying general relativity to the entire universe, Einstein suggested that the universe was static and spatially curved. Following from this, to explain the structure and dynamics of the universe, many interesting models based on Einstein's model have been proposed, such as flat and expanding universe, expanding flat space model, original Big Bang model, kinematic expanding models, oscillating or cyclic universe models, bubble universe and inflation bubble universe models, chaotic inflation model. Amongst these models, the Big Bang model has been the most accepted one. This is due to the cosmic microwave background, CMB, and cosmic redshift discovered by Hubble observations. Recently, in an observation, scientists confirmed that the cosmic microwave background does not prove that the hot Big Bang theory is correct. Well, as I said at the beginning, our universe is an open mystery to science. There are many mysteries in it, many questions to be answered, but the discoveries of our powerful telescopes are slowly uncovering the unknown mysteries of the universe. Hopefully in the future, we will be able to find the things we have predicted with our current theories. The comments section is open for us all to contemplate on this. Also, we now have channel memberships live, and please do take out some time to support us on the channel however you wish, but even a coffee at Starbucks will do.